This video, we're going to talk about exercises from 3.1, which is going to be solving for variables. We're going to have more complicated expressions and equations here, and we're going to have to solve for those sometimes in terms of other variables, sometimes to solve by factoring or some other method. So first question, is it possible to solve a cubic equation? They say statement, but they mean equation here. Something that's of degree 3. The answer is sometimes it's possible. Oftentimes it involves using the rational root theorem, hoping that there's rational roots. There is a generic cubic equation that exists like the quadratic equation, but you're not ready to do it at this point in pre-calculus because it involves having to know a very long formula, and it has complex numbers in the middle of it. So yes, it is possible, no matter what is in the form of ax cubed plus bx squared plus cx plus d equals 0. It's possible to always solve that. You just may end up with answers that are complex answers and not necessarily real answers to it. What are the possible types of solutions when solving a quadratic statement? Okay, we've got 4 cases that could come. So we could have case 1 is when the determinant, I'm just going to use capital D for the determinant, is equal to 0. Case 1 is going to give us 1 repeated root, and that means that the graph is going to touch the x-axis there. If case 2, D is a perfect square, then I'm going to get 2 rational roots that could be found by factoring. And this is going to give us 2 distinct rational x-intercepts that the graph will cross through. Okay. If D is positive but not a perfect square, we'll get 2 irrational roots from the quadratic formula. And we won't easily be able to graph those. We'll have to approximate the x-intercepts using our calculator. Because we're not going to be able to pinpoint them exactly since it's an irrational number. In case 4 is when the discriminant is less than 0. We get 2 complex roots in the form of a plus bi from the quadratic formula. And this tells us that there are no x-intercepts on the graph. Graph does not cross the x-axis then. Those are 4 cases. What is the maximum number of different solutions that a 7th degree statement could have? It could have up to 7 because of the fundamental theorem of algebra. An nth degree polynomial can have up to n different distinct solutions. True, false, a cubic statement can only have complex solutions. That's false. We could have something where we have 3 distinct linear factors like this, where x1 is equal to 1, x2 is equal to -2, and x3 is equal to 5. That would have given me a cubic equation or cubic statement. So it's not true that there's only imaginaries. But if we're going to work through the process, like the quadratic equation, to get to these answers from a generic statement, we're going to need to have knowledge of complex numbers to work through the arithmetic there. All right, determine the type of statement in terms of the given variable. So this is degree 3. This is a cubic statement in terms of x. For number 5, in terms of y, this is a linear statement. Everything else is considered a constant then. So this is linear because it's all degree 1. In terms of z, this is quadratic. This is squaring because its highest degree is 2. In terms of theta, this is not a polynomial, so I can't give you a degree because it's a cosine function here, and that's not a polynomial. In terms of x, this is a 4th degree statement. In terms of t, this is a 3rd degree statement. Determine if possible to solve the statement for the given variable. If it is possible, solve, but do not simplify the answer. If it is not possible, explain why. Let's take x, y squared minus xy is equal to 5y minus 3x. We're going to solve for x. So we're going to get all the x's on one side. X, y squared minus xy plus 3x is equal to 5y. We're going to factor out our x. And then we're going to divide. And I said, do not simplify. So we won't try and do any factoring or anything like that. That's what x is going to be equal to. Now we're going to solve the same statement instead for y. So I'm going to get all the y's together on one side. I'm going to see if I can divide everything through by x here. I can't do that. I can't divide. Yeah, I can. Let's divide everything through by x. that. Now I'm going to have y squared plus -1 minus 5 over xy is equal to -3. Need to take half of this, so let's write that as a -x minus 5 over x. Take half of it and square it. So we have 2x squared, that's 4x squared. Square the numerator is going to be x plus 5 squared. Give myself a little bit more room here on this problem. So -3 over 1 plus x squared plus 10x plus 25 over 4x squared. So this is going to be x minus x plus 5 over 2x. Quantity squared y. Let's simplify that a little bit if we can in just a second. Equals, and then we're going to have -12x squared plus x squared plus 10x plus 25 over 4x squared. Let's make this over 2x, so this is 2x squared minus x plus 5 over 2x quantity squared y is equal to -11x squared plus 10x plus 25 over 4x squared. So we're going to be able to multiply by the reciprocal of this now and say that y in terms of x is equal to -11x squared plus 10x plus 25. The 4x squareds are going to cancel each other out. This is going to give me 2x squared minus x plus 5 quantity squared in the denominator. And that is what y is going to be equal to. That was pretty gross, but it was doable. The question was solve if you can. So we did. 3t squared minus 5m cubed is equal to 8qt plus 2m cubed. Solve for the letter q. So we're going to get all the q's on one side by themselves, all the other letters over to the other side. We're going to factor q out. And we're going to divide by this piece that we don't want. And that leaves us with q equal to 3t squared minus 2m squared over 8t plus 5m. We're done. 2a squared b c cubed plus 3abc squared plus 4a squared c squared minus 3b equals 4c solve for A. So first thing, I want to get the stuff away from the A's that doesn't have anything in common with them. So 2a squared b, let's write everything with the coefficients 2bc cubed a squared plus 3bc squared a plus 4c squared a squared equals 3b plus 4c. So let's add these a squared parts together. 2bc cubed plus 4c squared a squared plus 3bc squared a is equal to 3b plus 4c. We're going to divide everything by this coefficient out here and get a squared plus 3bc squared over 2bc cubed plus 4c squared a equals 3b plus 4c over 2bc cubed plus 4c squared. Now we're going to take half of the middle term and square that. So that's going to be 3/2 squared is going to be 9/4. B squared c to the 4th over this, I'm just going to call 2bc cubed plus 4c squared squared. And I'm going to take this and instead of making it 9/4 looking like that, I'm going to make it 9/4 looking like that. I'm going to add 9b squared c to the 4th over 4 times 2b c cubed plus 4c squared. And on the left-hand side, I get a plus 3bc squared over 2 times the bottom is 4bc cubed plus 8c squared squared. Then I can try and make a common denominator here. But let's just write out what I have for right now. 2bc cubed plus 4c squared plus 9b squared c to the 4th over, let's call this 8bc cubed plus, oh no, that's squared. So this is 4 times 2bc cubed 4c squared squared. So let's go ahead to solve for a. Let's just say a is equal to negative 3bc squared over 4bc cubed plus 8c squared plus or minus the square root 3b plus 4c over 2bc cubed plus 4c squared plus 9b squared c to the 4th over 4 times 2b c cubed plus 4c squared, all that to the 2nd power. And we should get 2 answers here for A. Not pretty, but we can do it. All right, let's shrink this, go back up here to number 15. So far, we haven't seen one that we haven't been able to do. So 2a squared bc cubed plus 3abc squared plus 4a squared c squared minus 3b equals 4c, and we want to solve for b. So we're going to get all of our b's together. Let's make this 2a squared c cubed b plus 3ac squared b minus 3b, and we're going to get everything else away, is 4c minus 4a squared c squared. Right? There we go. B is a common factor in everything here. It's 2a squared c cubed plus 3ac squared minus 3 equal to 4c minus 4a squared c squared. So B is going to be 4c minus 4a squared c squared, all divided by 2a squared c cubed plus 3ac squared minus 3. Now we're getting into some more interesting problems. Log base 2 of xy equals x plus e to the z. Let's try and solve for x if we can. So we have log base 2 of x plus log base 2 of y equals x plus e to the z. I don't think that I'm going to be able to get all the x's together in a way where I'm going to be able to factor them out like I did before. There's no way to express this log base 2 of x in a way where I can solve exactly. So the only way to do this, so this can't be done. The only way to do that is going to be with graphing if I know what all the other numbers are. Let's try log base 2 of xy plus x, equals x plus e to the z, solve for z. So that one I can do. It's going to be log base 2 of xy minus x is equal to e to the z. And so that means that ln of log base 2 of xy minus x is equal to z. So number 17 was the only one that couldn't be solved with the methods that we know right now. The number 19 through 27, solve for x. Be sure to list all possible values of x. X squared minus 16 equals 0. So we're going to factor x plus 4, x minus 4, x plus 4 equals 0, or x minus 4 equals 0, x equals negative 4, or x equals 4. So my solution set is negative 4 and 4. X squared plus 16 equals 0. So that's not going to be factored over the reals, but I'm going to get all possible values, including imaginary values or complex answers. So if I get x plus 4i, x minus 4i, we talked about how factoring a sum of squares before like that. X plus 4i is equal to 0. X minus 4i is equal to 0. X is equal to negative 4i. X is equal to 4i. So those are my two answers. Say that you didn't know this factoring technique here across the complex numbers. So let's go ahead and let's use the quadratic formula instead to say my a is 1, my b was 0, and my c was 16. Negative b plus or minus the square root of b squared minus 4ac all over 2a plus or minus root negative 64 over 2 plus or minus 8i over 2 is plus or minus 4i. So we would have negative 4i and 4i as our solutions. X squared minus 4x plus, minus 7 is equal to 2. So we would like this to start off with this if we can. Are there any factors of 9 that we know they have a difference of 4? No, can't do that. So let's go ahead and make this over here, take half of the middle number and square it. X minus 2 squared is equal to 13. X minus 2 equals plus or minus root 13. X equals 2 plus or minus root 13. Those are my answers that I would get from the quadratic formula. 2 minus root 13, 2 plus root 13, and I got those answers from completing the square instead of using quadratic formula. Now we're going to have x squared minus 2x plus 7 is equal to 2. We have x squared minus 2x plus 5 is equal to 0. Any factors of 5 that add to give me negative 2? No. So I'm going to separate these. Take half of the middle number and square it. X minus 1 squared is equal to negative 4. X minus 1 is equal to plus or minus 2i. X is equal to 1 plus or minus 2i. So my solutions are 1 minus 2i, 1 plus 2i. Five x squared plus 2x is equal to negative 1. Let's see if perhaps I can bring this about where, no, that's not going to work. I'm just going to show you it's not going to work. There are no factors of 5 that add to give me 2. So I'm going to go ahead and divide everything by 5 here. X squared plus 2/5 x, negative 1/5. Half of the middle number squared is 1 over 25. So this is x plus 1/5 squared. This will be times 5 over 5. 1 minus 5 is going to be negative 4 over 25. X plus 1/5 is equal to plus or minus 2i over 5. X is equal to negative 1 plus or minus 2i over 5. X is equal to negative 1/5 plus or minus 2/5 I. So my two answers here are going to be negative 1/5 minus 2/5 I, negative 1/5 plus 2/5 I. Let's see if we can verify that solution with the solutions with the quadratic formula instead. So let's come back up here to the beginning. Let's erase all this. See if we can get to that same answer a different way. So my A is 5, my B is 2, and my C is 1. Negative B plus or minus the square root of B squared minus 4AC all over 2a is those are all even numbers. And I get the same answers. That was number 23. Let's move on to number 24. X to the third is equal to 8. X cubed minus 8 is equal to 0. This is the difference of cubes. Don't forget the factor. It's easy enough to see that the answer 2 would work, but what about this other part? We know x minus 2 equals 0, or x squared plus 2x plus 4 equals 0. We forget about that part lots of times. So we're going to say x squared plus 2x is equal to negative 4. Half of this number squared is 1. So we get x plus 1 quantity squared is equal to negative 3. X plus 1 equals I root 3 plus or minus. X is equal to negative 1 plus or minus I root 3. So we have negative 1 minus the square root of 3 times I, negative 1 plus the square root of 3 times I. And those, I also have a third answer here of positive 2. Those are my 3 answers to my cubic. X to the third plus x squared equals 4x plus 4. Let's bring it over, set it equal to 0. Let's try to factor by grouping if I can first. Be x plus 1 times x squared minus 4 equal to 0. That's x plus 1, x plus 2, x minus 2. That means x plus 1 equals 0, or x plus 2 equals 0, or x minus 2 equals 0. So my first answer is negative 1, my second answer is negative 2, and my third answer is positive 2. Let's write them in ascending order: negative 2, negative 1, and 2. 26, 2 times x minus 3 quantity squared minus 7 is equal to negative 4x plus 9. I'm going to have to expand the left-hand side first. This is 2 times x squared minus 6x plus 9 minus 7 equals negative 4x plus 9. So 2x squared minus 12x plus 18 minus 7 equals negative 4x plus 9. And bring everything over to the left-hand side. So plus 4x minus 9 is equal to 0. It's going to give me 9 minus 7 is 2. Negative 12 plus 4 is negative 8. Everything's a multiple of 2, so this is the same thing as this. There are no factors of 1 that are going to add up to give me negative 4. So I'm going to take the negative 1 over, half of this squared. That x minus 2 squared is equal to 3. X minus 2 equals plus or minus root 3. And x is equal to 2 plus or minus root 3. So my solution set is 2 minus root 3 and 2 plus root 3. Now for number 27, x plus 2 to the third is equal to 2x squared plus 8x plus 7. Going to expand this, x to the third plus 3 times x squared times 2 to the first plus 3x times 2 to the second plus 2 to the third equals 2x squared plus 8x plus 7. This is off of Pascal's triangle that I showed you earlier. X to the third plus 6x squared. 4 and 3 makes 12x. That's 8. 2x squared plus 8x plus 7. So we have x cubed. 6 minus 2. It's going to be 4. 12 minus 8 is also 4. 8 minus 7 is 1. So now we are going to have to, I'm going to use a factoring technique here that I think is going to work. I'm going to group those, and I'm going to group these. Typically, we don't factor this way, but I think that it's going to work here. So this is going to be x squared minus x plus 1. This is 4x times x plus 1. I see the x plus 1 is common. It's going to leave me with x squared minus x plus 1 plus 4x is equal to 0. That's x squared plus 3x plus 1. So we are going now to set each factor equal to 0. X equals -1. I'm not going to try the quadratic formula on this one. This one I'm going to solve by completing the square. Half of the squared is 9/4. This is 4 over 4. X plus 3 halves squared equals 5/4. X is equal to -3 halves plus or minus √5 halves. So it is -3 minus √5 over 2, -3 plus √5 over 2, and those are my two answers. Oh my goodness, I was not paying attention to all the different types of solutions, but for 16 we have 2 rational solutions. Number 20 we had 2 complex solutions. Then in 21 I believe we had 2 irrational solutions. Let me check to make sure of that. Equals 9 over here, half of this number squared, 4, yeah. So we had 13, and that's going to be, this is x minus 2 equals plus or minus, yes. So we're going to have 2 irrational solutions in 21. Then in 24, we have 1 rational and 2 complex. And in 25, we had 3 rational, I believe. And we had yes. We had x plus 1 times x plus 2 times x minus 2 was equal to 0, and we came up with 3 rational solutions to it. Okay, so that is it for this section. Next time we come back, we're going to talk about intersections between graphs and how to solve and find those points of intersection when possible. Right, see you for the next video.